In this video tutorial, we're going to analyze questions from part 1 of the June 2018 Geometry Regents, and we'll start with question number 1 that says, after a counterclockwise rotation about point X, scaling triangle ABC maps onto RST as shown in this diagram right here. Which statement must be true? The first thing that I'm going to do is analyze these triangles and determine which parts are corresponding. I recognize that order matters, and I know that A corresponds with R. And so what we're going to do is I'm going to circle A and R. I'm going to circle B and C because that's the second vertex listed in the sequence. So B and S correspond. Likewise, C and T correspond. And we know that corresponding parts are congruent. So which statement has got to be true? Well, I see it says angle A is congruent to R. And I notice that this is red and R is red. And those certainly do match up. These are congruent. But let's go through just so we can rule out options 2 through 4. I noticed that 2 says A is congruent to S. Red and blue do not match up. So those are not congruent. 3, CB is congruent to TR. So CB, orange, blue, TR, blue, red. Nope, those are not aligned. And then CA is congruent to TS. So CA, green, red. TS, green, blue. No, that's not a viable option. The correct answer is A. Angle A is congruent to angle R. Question number 2 says, in the diagram below, AB is parallel to DEF. So before I do anything else, I'm going to simply mark this up to indicate that they're parallel. And it says AE is and BD intersect at C. Angle B is 43 degrees. Angles CEF is 142. Which statement is true? So I notice it's asking us about angle DA, ACD, and BCE. I'm going to mark this up also just so it's clear for me what we should be highlighting. So we're looking for angle D, which is right here, angle A. Okay, it says angle ACD, and then angle BCE, which is right there. Great. So let's fill in the gaps with what we already know. So I recognize a few things. I can see that because AB and DEF are parallel, we've got a transversal cutting across here. We got a transversal cutting across here. And we remember that if we've got two parallel lines that are cut across by a transversal, that we've got something called alternate interior angles, and they are congruent. And we actually have that right here. And I noticed that if this is 43, we've got alternate interior angles making CDE also 43 degrees. I also notice a linear pair right here. So if this is 152 degrees, this angle right here is going to be 180 minus 152. And 180 minus 152 is simply 28 degrees. And then once again, if we've got two parallel lines cut by a transversal, we've got the alternate interior angles. And angle BAC is also going to be 28 degrees. Tremendous. How can we figure out what this angle is and this angle is? Well, if we figure out one, we can figure out the other because they are a vertical pair. And I also remember that the sum of the three interior angles of a triangle add up to 180. So what we can do is the inverse. If we do 180, so that right now, 180 minus 43 minus 28, we get 109. So this has got to be 109 degrees, this has got to be 109 degrees, and then finally, because this is a linear pair, that's going to make this 71 degrees and BCE also 71 degrees. So now let's take a look at our options. Which statement is true? Angle D. Is angle D 28 degrees? No, angle D is 43, so we can simply rule that out. Not option 1. Angle A is 43 degrees. Angle A is not. Angle A is 28, so we can rule that out. Let's take a look at option number 3. ACD, 71 degrees. So I'm going to look at ACD, and it is 71 degrees. So that looks like it's probably the correct answer. We'll rule out option 4. BCE is 109. BCE is not 109 degrees. It's also 71. The correct answer for question number 2 is option 3. ACD is equal to 71 degrees. Let's take a look at question number 3. It says in the diagram below, line M is parallel to line N. And figure 2 is the image of figure 1 after a reflection over line M. And figure 3 is the image of figure 2 after a reflection over line N. So it looks like there was 2 steps to get from here to here. The question is, which single transformation would carry figure 1 onto figure 3? And so let's evaluate our 4 options. The first option is a dilation. Well, we know a dilation increases or decreases the size of the object, and we can rule that out because that's not going to transfer us from, that's not going to get figure 1 to figure 3. When we take a look at option 2, it says a rotation. If this spun, that's not going to shift this triangle over to figure 3. A reflection, nope. But what I do know is that a translation would work because I noticed that 1 and 3 have the same orientation. They're just in different locations, so it's just shifting from here to here. And the correct answer is, of course, option 4, translation. Let's take a look at question number 4 in the diagram below. AF and DB intersect at point C. AD and FB are drawn such that angle D is 65 degrees. CBE is 115. I noticed that DC is 7.2, AC is 9.6, FC is 21.6. Our objective is to figure out the length of CB. That's this length right here, and I'm going to mark that right now with an X. All right, so how are we going to figure out what CB is? Well, the first thing that we're going to need to do is establish similarity between these 2 triangles so that we can then set up a proportion. And on further inspection, I noticed that this angle right here forms a linear pair relationship with CBE, and 180 minus 115 is going to give us, of course, 65. And so if this is 65 and this is 65, we've got 1 pair down. I also noticed that when we look at these 2 triangles, angle DCA and FCB are congruent because of vertical pairs. So great, we just established angle-angle similarity. This is great. So now what we're going to need to do is set up this proportion, and I know that AC over FC equals what? DC over BC. And again, this is what we're trying to figure out right here. So now let's plug in the numbers and the variables, and we'll see if we can solve for x. So I know that if it's AC right here, 9.6, it's going to be 9.6 over 21.6. And so let's write that down. 9.6 over 21.6 equals 7.2, right, DC, over, we don't know what x is. That's what we're solving for. What we're going to do right now is we're going to simply cross multiply. So 9.6 times x, of course, is going to give us 9.6x equals 21.6 times 77.2. It gives us 155.52. And then when we divide both sides by 9.6, x equals 16.2. So CB equals 16.2. Let's see if that's an option. Its short is. We can rule out 1, 2, and 4. The correct answer is option number 3, 16.2. Let's take a look at question number 5. It says, given square RSTV, I'm going to draw a little visual, where RS is 9 centimeters. If square RSTV is dilated by a scale factor of 3 about a given center, what is the perimeter in centimeters of the image RSTV after the dilation? So it's increasing in size by 3. And so after the dilation, RS is no longer 9. We're going to multiply by 3, and that, of course, is going to give us 27. If we're looking for the perimeter, we're going to need to add up each new side, and I know that 27 times 4 is going to give us 108. And this is the new perimeter. Correct answer is option number 4. Alternatively, if you simply multiplied 9 times 4, we know that that gives us 36. And then 36 times 4, I'm sorry, 36 times 3 gives us also 108. So that's another way to determine what the perimeter is of this new image. Question number 6 says, in right triangle ABC, so I'm going to sketch this out right now. You got ABC. It says AB has a length of 26 centimeters. Okay. And that, of course, is the hypotenuse. And BC has a length of 17.6 centimeters. What is the measure of angle B? So our objective is try to figure out what is the measure of this interior angle right here to the nearest degree? Well, I know that we're going to use our trig ratios, and I recognize that here, when we're looking at this from the perspective of angle B, we've got adjacent and hypotenuse, and that of course is going to be the cot in SOHCAHTOA, and so we're going to be looking for cosine. So we know that the cosine theta equals adjacent over hypotenuse, so it's going to be 17.6 over 26. Amazing. And because we don't know the degree, what we're going to be doing is the inverse of it. So we're going to do theta equals the inverse of cosine, 17.6 over 26. And when you pop that into your calculator, the this unknown angle is going to be 47.396 degrees. And because this is saying that we need to determine what it is to the nearest degree, don't be fooled. The nearest degree is 47, not 48. So option number 2 is the correct answer. Question number 7 says, the greenhouse pictured below can be modeled as a rectangular prism with a half cylinder on top. The rectangular prism is 20 feet wide, 12 feet high, and 45 feet long. The half cylinder has a diameter of 20 feet. So our objective is to determine to the nearest cubic foot what is the volume of the greenhouse. And to determine that, we're going to need to be applying our volume formulas carefully. And so I'm going to sort of split this greenhouse into two parts. We've got the volume of this half cylinder, and we've also got what else? We've got the volume of this rectangular prism. I'm just going to abbreviate a little bit. So what is the formula of the volume of the half cylinder? We remember that it's 0.5 times pi times r squared times the height. The volume of this rectangular prism, of course, is length times width times height. So let's plug in our values, add both the half cylinder and the rectangular prism, and we'll get the volume of the greenhouse. So I know that it's going to be 0.5 times pi times r squared. What is the radius? Well, the diameter is 20, so the radius is going to be simply 10. So it's going to be multiplied by 10 squared. And then the height. This is a little bit tricky. I recognize that this cylinder is on its side. So what we would normally think of the height is, in this context, the length. And that's going to be 45 feet. So let's plug in that value. Great. Plus what? Well, we know that the length is going to be simply 12 times 20 times 45. Great. And so when we take out our handy dandy calculator and we plug this in, we're going to determine that this is 2,250 pi plus 10,800. And so the cubic foot volume of this greenhouse is, when we add these two together, is 17,868.58347 cubic feet. Is this an option? It sure is. It's option number 1. Amazing. Question number 8. In a right triangle, the acute angles have the relationship sine 2x plus 4 equals cosine 46. What is the value of x? Well, what do I remember? In a right triangle, the acute angles are complementary, meaning that these two angles add up to 90 degrees. So what we can do is simply set this as 2x plus 4 plus 46 equals 90 degrees. That makes sense, and I know that 2x plus 50 equals 90, and I know that when we subtract 50 from both sides, 2x gives us 40, and then so x equals 20 degrees. Is this an option? It sure is. The correct answer is option number 1. Question number 9 says in the diagram below, AB is congruent to DCF, and EDA is congruent to CBG. All right, and it says segment EFB and segment AG are drawn. Which statement is always true? And I noticed that on the left side we've got two sets of triangles that are congruent to one another, and options 3 and 4 we've got two sets of triangles that are similar to one another. And when we analyze this diagram, I don't see any instances in which we have a pair of congruent sides, and so if we don't have any congruent sides, we cannot prove triangles congruent. So right off the bat, we can eliminate options 1 and 2. So we're going to need to establish a similarity between some of these triangles, and I recognize that we're looking for angle relationships, and when we're looking at these two sets of parallel lines right here, and we've got a transversal cutting across from E to A, this angle and this angle are corresponding, and that indicates that they are in fact congruent. Likewise, on the opposite side, we've got that same set of parallel lines with a transversal cutting across, this time from E to B. We can indicate that this angle and this angle are corresponding and also congruent. So what we can do is use this information to establish that triangle DEF is similar to AEB. Correct answer is option 4. Question number 10 says the base of a pyramid is a rectangle with a width of 4.6 centimeters and a length of 9 centimeters. Our objective is to determine the height in centimeters of the pyramid if its volume is 82.8 cubic centimeters. Great, so the first thing that we're going to need to do is jot down the formula for the volume of a pyramid. And we know that the volume is 1/3 times the base times the height. And we also remember that the base is the length times the width, right? So let's plug this in and determine what the height is, because that is our objective in this problem. We know the volume, we know we can figure out what the base is. Let's see what the height is. So the first thing that we're going to do is plug in for volume 82.8 equals what? 1/3, and then the length is what? 9. The width is 4.6 times the height. So when we take out our handy dandy calculator, we know that 9 times 4.6 is going to give us 41.4. And then when we want multiply 41.4 times 1/3, that's going to give us, that's going to give us simply 13.8. And we're solving for height, so we're going to need to divide both sides by 13.8. And when we do, we know that height is 6. This is our answer. The correct option is option number 1. Let's take a look at question number 11. The diagram below, right triangle AED, it says that BC is parallel to DE. Which statement is always true? And I see 4 sets of proportions. That means that we're going to have to set up and determine similarity between this small triangle and this big triangle. How are we going to go about doing that? Well, I know that BCA is congruent to DCA because they're both indicated as 90 degrees, but also because we've got these parallel lines with a transversal cutting across, and I can see that these are corresponding angles. What other angle relationships do we have here? Well, we've got that same set of parallel lines with the transversal cutting across from A to D, and that would indicate that this angle and this angle are corresponding. so that angle ABC and angle ADE are also congruent. We just established similarity, so we've got triangle ABC is similar to triangle ADE. Great, so now which statement is always true? Sometimes what I like to do is simply just highlight the small triangle and its relationship to the big triangle. And I know that when I look at these four proportions, option number 2 is the correct answer, and let's think about why. So I see that we've got the hypotenuse of the small over the hypotenuse of the big equals the short side of the small, right, this blue triangle, over the short side of the big. So we've got AB over AD equals BC over DE. So you're going to think about the order of the letters. You're going to think about what it looks like visually to establish that this proportion is in fact true. Let's take a look at question number 12. It says, what is an equation of the line that passes through point 6.8 and is perpendicular to a line with the equation y equals 3 halves x plus 5? So the first thing that we're going to need to do is determine the perpendicular slope. And I know that the slope here is 3 halves, right? So the perpendicular slope, you probably recall, is the opposite reciprocal. So we're going to flip the numerator and denominator, and we're going to make it from a positive to a negative. So it's going to be negative 2/3. Great. So this is going to be the new slope, and we can actually eliminate option 1 and 3 because I see that they both have the original slopes, like 3 halves, and we don't want that. So it's going to be either option 2 or 4. And we also recall that point slope form is written like y equals y1 equals m times x minus x1, right? And so when we look at this original equation, we can see that 6 is x1 and 8 is y1. I'm going to rewrite the equation now, simply popping in the new x and y values. And when I do that, I know that y is simply positive 8, and that x1 is simply 6. And I, of course, remember that m is now negative 2/3. Is this equation either option 2 or 4? It sure is. It matches up with option 2. Can't be option 4, I can see, because there's that x plus 6, and we know that it's negative. So correct answer is option number 2. Question number 13. The diagram below shows parallelogram ABCD with diagonals AC and BC intersecting at E. What additional information is sufficient to prove that parallelogram ABCD is also a rhombus? All right. Well, is it that BD bisects AC? Nope. AB is parallel to CD? No, not necessarily. AC is congruent to BD? Definitely not. But AC is perpendicular to BD? Yeah, that's one of the properties of a rhombus, and so I'm going to include that little mark indicating that that angle is 90 degrees, that AC is perpendicular to BD. This is the correct answer. Question number 14 says, directed line segment DE has endpoints -4, -2, and 1 and 8. Point F divides DE such that DF to FE is a 2:3 ratio. So that means it's going to be 2 parts on one side, 3 parts on the other. What are the coordinates of F? Let's sketch that out. I really like to visualize something like this. We know that point D is on one end, E is on the other. We recognize that this is a 2:3 ratio, so it's going to be broken up into 5 equal parts. And F is this point right here. So this is what we're looking for right here. We need the x and y value for F. What I'm going to do right now is I'm going to write down the x value for D, which is -4, and the x value for E, which is 1. And I know the y value for D is -2, and the y value for E is 8. All right, so we've got our coordinates. What I want to do is determine how much the x values are increasing by for each unit. So we're going to find out the entire distance from D to E. And I'm going to start at the end, 1 minus -4, and that gives us 5. All right, the x values increased by 5 from D to E, and the and the y values increased by how much? So we're going to do 8 minus -2 for a total of 10. Now what we need to do to determine how much they're increasing by for each part is we're going to divide it by the total number of parts. So 5 divided by 5 is 1. 10 divided by 5 is 2. Oh, okay. So what does that mean? That means that this next coordinate right here, if it's increasing by 1, is going to be -3, 0. Oh, okay. And then what is the next one? So if it's increasing by 1, it's going to be, f is going to be what? -2, comma 2, and then so on and so forth. So is -2, comma 2 an option? It sure is. It's option number 2. And that, ladies and gentlemen, is the correct answer. Oh, Question 15. Triangle DAN is graphed on the set of axes below. The vertices of DAN have coordinates -6, -1, 6, 3, and -3, 10. Our objective is to figure out the area of triangle DAN. How are we going to do that? A few different methods we could use. We could use the shoelace method. Alternatively, we can use the decomposition method, which is when we box in this triangle and then subtract out the area of this triangle, and this triangle to get the area of triangle DAN. And in fact, that's what we're going to do right now. So the first thing that I'm going to do is sort of encase this in this rectangle. I'm going all the way till where I see each vertices is lined up with the edge of this rectangle. And then we're going to add a cross, and I know that up and down is 11 units, and I know that across is 12. And so the area of this box, or this rectangle, is 11 times 12 is 132. Great. So now what we're going to need to do is figure out what is the area of this triangle. And we'll start with this individual triangle right here. And so when we're looking at it, I can see that the area is, well, we know it's 1/2 base times height. And so I know that it's going to be, or base times height divided by 2. So it's going to be 1/2 times 11 times, it looks like it's 3 across. And so that gives us 33 halves. That gives us 16.5. All right, so we got 16.5. What about this one over here on the right side? I can see that it's going to be how many across? 1, 2, 3, 4, 5, 6, 7, 8. 9 times 1, 2, 3, 4, 5, 6, 7. 9 times 7, which is 63, divided by 2. And that gives us 31.5. That looks great. Down here I see we've got 12 across and 1, 2, 3, 4 up. So 12 times 4 divided by 2 is what? 24. Great. So now what we're going to do is 132. I'll do this right here. 132 minus the sum of the other three triangles that we're going to be ultimately subtracting. So it's minus 24 plus 31.5 plus 16.5. Great. And so that gives us 132 minus 72. 132 minus 72 is 60 square units. That's option 1. Amazing. So the area of triangle DAN is 60. Let's take a look at question 16. And it says a triangle ABC with vertices A, B, and C is graphed on the set of axes below. Which figure is formed when AB is rotated continuously about BC? So if this is rotated continuously about BC, I know that it's going to be rotated around this sort of segment right here, and it's going to look a little something like this. So if it's rotated around it, it's going to look a little bit like this. You can sort of imagine what that would look like. And so that means that BC is the height. So if BC is the height, this has got a height of 3 units. That's the height. Let's take a look at our 4 options. Well, what do we know? I can see that the height of options 1 and 2 are 5, and that's that's not a good look. We don't want that. We're looking for a height of 3, so we can nix option 1 and 2. Let's take a look at options 3 and 4 a little bit more thoroughly. I can see that here the diameter of option 4 is 5, but when we take a look at option number 3, the diameter is 10, and that would make sense because you'll see that the radius right here is 5. So the correct answer is option number 3. Question 17. In the diagram below, circle O, chords A, B, and CD intersect at E. So it says if arc AC is 72 degrees and angle AEC is 58, how many degrees are in arc DB? So this is our objective, and we're going to need to figure this out. Well, what do we remember? We remember that if two chords intersect inside a circle, like we have right here, this angle equals 1/2 this arc plus this arc. All right, so let's write down that formula and then let's sort of fill in the blanks. So we know that angle AEC equals 1/2 arc AC plus angle DB. I'm sorry, arc DB. And we also remember that if it was outside the circle, it would be minus rather than plus. All right, so let's plug in these values. Instead of angle AEC, we're going to write 58 equals, let's see, 1/2. And then instead of arc AC, we're going to write 72 plus, we don't know what arc DB is. So we're going to leave that like so. All right, and so we're going to need to isolate ultimately this variable, of course. We're going to multiply both sides by the reciprocal of 1/2, which is 2. And we multiply both sides by 2. Let's do that right now. Multiply the left side by 2. We'll multiply the right side by 2. 58 times 2 is going to give us 116. And we're left with 72 plus arc dB. Let's subtract 72 from both sides. And arc dB equals what? 44. Amazing. Is that an option? It sure is. Option 3 is 44 degrees, so arc dB is 44 degrees. Question 18 says, in triangle SRK below, medians SC, KE, and RL intersect at M. And then it says, which statement must always be true? Well, the key word in this statement for me is medians. And we remember that a median is the line segment that connects the vertex right here to the midpoint of the opposite side of the triangle. And so it's doing that for each of these three vertices, right? SK and R. And that this intersection right here, this is called the centroid. Now, what's unique about the centroid? It cuts the medians into a 2-to-1 ratio. So that means that this, for example, is x. This would be 2x. Likewise, ML is one segment or 1 unit. RM is going to be 2 units. And so what exactly does that mean? That means that MC is 1/3 the length of this entire segment SC. ML is 1/3 of RL. In contrast, MK is 2/3 of EK. All right, so what statement has always got to be true? Well, when I look at the first option, I see it says that 3 times MC equals SC. So SC is this entire, is the length of this entire segment right here, yes? And MC is this short segment, right, from the centroid to the median of the opposite side. So 3 times MC equals SC. That makes sense, right? Because once again, MC is 1/3 of this entire segment. Option number 1 is the correct answer. Question number 19 says, the regular polygon below is rotated about its center. Which angle of rotation will carry the figure onto itself? So whenever I'm doing a problem like this, I like to draw an interior circle. That's going to help us find the central angle. What I then like to do is pinpoint the center. And I remember that there are 360 degrees in a circle. And so we're going to slice this bad boy up into 5 pieces. I noticed that there's 5 sides. And so what we're going to do is 360 divided by 5, and that gives us what? 72 degrees. So each central angle is 72 degrees. Now the question says, which angle of rotation will carry the figure onto itself? So if we rotated it 72 degrees, this corner would simply shift to right here, but sadly, 72 is not an option. We've got 60, 108, 216, and 540. I know that if you take out your handy dandy calculator, you will realize that 72 is a multiple of only 216. So 216, option number 3, is the answer. Question 20 says, what is an equation of circle O shown in the graph below? So the first thing that we need to do is know the equation of a circle, which we remember is x minus h squared plus y minus k squared equals radius squared. We also remember that the hk values are the center of the circle. And in this case, what I'm going to do is I'm going to count over, and we need the x values first. So I'm going to count over 1, 2, 3, 4, 5. So h is 5. All right. And the y, I can just eyeball it and see it's 2. All right. So we know what h and k is. What about the radius? The radius is when we sort of start from the center and count out 1, 2, 3, 4. The radius is 4. All right. So we know what the center of the circle is. We know what the radius is. Now let's pop this in and see if we can simplify to figure out which of the 4 options is the correct answer. So I'm going to write x minus, and I'm going to simply pop in the values in a moment. Okay, we know that it's going to be x minus positive 5, y minus positive 2 equals 4 squared. And now what we're going to need to do is we're going to need to FOIL x minus 5. And so we know that x times x is what? X squared. X times -5 is -5x, and then if we're doing the first outer inner last, it's going to be again -5x, and then it's going to be -5 times -5 is positive 25. So that's going to look like this. And you guys are going to want to do that on a separate piece of paper if possible. Y minus 2 squared, similarly, is y times y is going to give us y squared. Y times -2 is -2y plus -2y plus positive 4. So that's going to look like minus 4y plus 4 equals 4 squared is going to give us 16. So now what we're going to do is we're going to simply subtract 25, and we're going to subtract 4 from both sides, and we are left with x squared minus 10x plus y squared minus 4y equals what? So it's 16 minus 25 minus 4. That's going to give us 13. Sorry, negative 13. Is that an option? Let's take a look. It certainly is. It is option number 2. Great. If you have any questions or experiencing a little bit of confusion about this step right here, just review how to FOIL binomials, how to multiply binomials, and you should be good. Question 21 says, in the diagram below, triangle PQRST is drawn parallel to PR. So I'm going to indicate that like so. And it says PS is 2, and we see that SQ is 5, TR is 5. Our objective is to figure out what is the length of QR. All right. But what do we not know? We do not know what QT is. We're going to need to set up a proportion. So how can we do that? Well, I know that if the line is parallel to a side of the triangle, which is what we have right here, and it intersects this side and this side, then it divides these sides into segments of proportional length. So let's set up that proportion. So it's going to be QS over SP equals to QT over TR. And so that's going to look a little something like this. So we said it's QS, which is 5, over SP, which is 2, equals, we don't know what QT is, so I'm simply going to call this X, equals X over TR, which is 5. Great. And so we're going to simply cross multiply, and I know that 5 times 5, of course, is 25 equals 2x. That means that x is 12 and a half. Is 12 and a half our answer, or is that not what it's looking for? I can see it says, what is the length of QR? And again, that's that sort of red segment that I highlighted earlier. So we know that QT is 12 and a half. That means that QT plus TR is 17 and a half, right? 12 and a half plus 5 is 17 and a half. Option 4 is our correct answer. Question 22 says, the diagram below shows circle O with radii OA and OB. The measure of angle AOB is 120 degrees. The length of the radius is 6 inches. Which expression represents the length of arc AB in inches? So that's our objective right now. We need to figure out the length of AB. And I remember that the formula for arc length is what? It's equal to theta over 360 times 2 pi r. And so what we're going to need to do is plug in the values so we can figure out what the arc length is. So the arc length is equal to how many degrees in this central angle. I can see that it's 120, so it's going to be 120 over 360 times 2 pi, and what's the radius? It's 6, right? And so can we simplify? We sure can. 120 divided by 360 is going to give us 1/3, and 2 pi, 2 pi 6 is going to give us simply 12 pi. Great. So the arc length is 1/3 12 pi. Is that an option? Let's see. It is. It's option number 4. Question 23. Line segment CD is the altitude drawn to hypotenuse EF in right triangle ECF. So in a moment I'm going to draw that triangle. It says if EC is 10, EF is 24, and then to the nearest degree, how much is ED? All right, so the first thing I'm going to do is I'm going to sketch out this right triangle, ECF, and it's going to look a little something like this. Great. I know it's a right triangle, and I know that it's ECF, so I'm going to label it ECF. Great. And it says that there's a line segment, CD is an altitude. All right, so I'm going to draw this altitude right here. Great. And this also makes a 90-degree angle. This is D. Tremendous. It says if EC is 10, okay, if EC is 10 and EF is 24, all right, so this entire length is 24. Our objective is to figure out what ED is. All right, so we need to figure out the length of the short side of this smaller triangle. There's a few different ways we can approach this. We're going to use the geometric mean. How do we approach that? Well, let's do some quick review. We know that if we've got a right triangle with an altitude, we've got a 90-degree angle here, we've got a 90-degree angle here, and if we label this A, this is B, we remember that this is X and this is Y. To figure out a component, we're going to need to set up the equation, and we remember it's a squared equals x times x plus y. All right. So right now, if we were looking for example, this side, we would plug in values for x and y, and we're going to be applying this idea, this formula, to this equation right here. So what do we know? We know that EC is 10, so let's find some space. It's going to be 10 squared plus x. We don't know what x is, do we? So I'm going to leave that like so. And in our formula, we remember that it's x plus y. It's the sum of this hypotenuse of the big triangle. In this case, they told us that it's 24, so we're going to be multiplying x by 24. Great. So 10 squared, of course, is 100 equals 24x. We're solving for x, so when we divide both sides by 24, x is what? It's 4.2. Is that an answer? So when we take a look at our four options, it is. It's option number 1. Amazing. Last question, number 24. Line MN is dilated by a scale factor of 2, centered at the point 0.6. If line MN is represented by y equals negative 3x plus 6, which equation can represent m prime, n prime, the image of MN? And we've got 4 different options. We need to scrutinize this a little bit further, though, because this question is kind of tricky. So if we wanted to sort of graph this, we recognize that if it's at 0.6, it's going to be approximately, let's say, right there on the y-axis, and that it's probably looking a little something like this, right? Down 3 over 2, down 3 over 2. So that's MN. It says if line MN is dilated by a scale factor of 2 centered at the point on the line, which it is, what is it going to look like? Well, dilation of a line centered on the point on the line, it results in the same line. So this isn't going to change. It's not going to shift. So it's going to be the same equation, y equals negative 3x plus 6. Is that an option? In fact, it is. It is option number 2. That is the correct answer.